Hello ladies and gentlemen, welcome back. This video tutorial is for the first half of the DSA, getting through all of the questions as many of the questions as possible so that nothing will be a surprise for you when you take basically the chapter 1 test. So first things first, we're going to start talking about functions. And a lot of kids kind of struggle with at first until I give them something really easy. The whole big thing about functions is that the only thing that matters is the domain. So we can literally cover up the range, and now we can start going through the picture. And here is the key thing. You always want this to be pointing, point to 1. So points to 1, points to 1, points to 1, points to 1, points to 1. It's a pass. It's a function. Over here, points to 1, points to 1, points to 2. Let me show you that a little bit clearer. Copy, fill this in, and you can see that that this is pointing to two things. It's going first here, and then it is going here. That makes this a fail. So visually, that's one of the easiest things in this particular type to do. Over here, when they give it to you as a list like this, you're looking at your first letter only, and the question you are asking yourself is, does it repeat? F, D, Z, G. Is any of that repetition? No. Pass. It's a function. 6, -4, 4, 1. Is any of it repeat? No. Pass. It's a function. That's what you're going to be doing for these. And they tend to give it to you basically in 2 to 3 flavors. So again, points to 1, points to 1, points to 1, points to 1, pass. Points to 1, 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 pass. That's what you're looking for. Does it repeat? 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 Yes, it repeats. That's a fail, so it's not a function. Over here, does it repeat? 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 No. Pass. It is most definitely a function. That's what you're going to be looking for. You're identifying for functions. Another way visually to identify functions is something called the vertical line test. And this is literally what it says on the tin. What you're going to do is you can take, what I tend to do is I take, on a computer, I tend to take my ID and I'm just going to draw a vertical line. And the question I'm asking myself is, does it pass through more than 1 point? So like over here, it passes through 2 points. Automatic fail. Over here, I'm trying to arrange it, passes through 2 points. Fail. Over here, passes through 1, good. Passes through 1, good. Passes through 2, fail. Not a function. That's what you're visually doing. Passes through 1, passes through 1, passes through 1, passes through 1. Pass. That one is a function. Over here, I can do it as many times as I want, but wherever I draw my vertical line, it's always going to pass through only 1, therefore it's a pass. Over here, this is the part where it's really tricky, but remember, this dot over here is open. That means it's not actually anything there. It's only there if it's filled in. So this does, in fact, get a pass. But there's one over here where, okay, yeah, that's a pass, sure, but what about over here? That passes through 2 points, and therefore that is a fail. That was the hard one. So again, this part makes you think that it's a pass, but this is the part that makes you realize it's a fail. It's not a function, okay? Moving on, let's see here. Vertical line, only 1, only 1, only 1, only 1. This is a pass. Only 1, yep, this is a pass. Only 1, nope, this is a fail. Only 1, ooh, first try, this is a fail. Only 1, nope, this is a fail. It's easier visually if you have your ID to just sort of visually scrape it along the actual function, but I don't have the ability, so I have to draw 106 lines. Now, this one of the easiest questions on the DSA, domain and range. Domain, it is worth remembering, is always going to be your X, and then range, again, it's worth remembering, is always going to be your Y, assuming my computer will catch up because lag. Come on, computer. Good. So, domain, again, we need to have the very, very technical term of squiggle brackets in order to write our first term. So what's our X? What's our X? What's our X? It's going to have 3, -7, and -4. That's all you're doing for this. Again, squiggle brackets, what are our Y's? We have 6, 0, and do we need to write 6 again? Nah, so we're all set. Domain is going to be, what's in our squiggle brackets? We have the 9, the 5, and the 7, so 9, 5, 7. And then for range, what are we going to have? Squiggle brackets. Let's see, we have a 7, a B, and a B. So 7 and B. And that's it for domain and range. It's actually one of the easier ones. Next, table for a linear function. Let's take a look. All you're doing is that negative 4x minus 3. All you're doing is plugging in every single number they give you. So the first one they give us, for example, is a negative 4. So instead of writing x, we're going to put negative 4. What's negative 4 times negative 4? It's going to be 16 minus 3, which is 13. Okay, that's my first one. Next, what do? We're going to have negative 4 times 0 minus 3. Well, negative 4 times 0 is 0, minus 3 is going to be negative 3. So far, so good. We're doing okay. Negative 4 times 1 minus 3, that is going to be negative 4 minus 3, because 1 times any number is itself, so that will be negative 7. Negative 4 times 2 minus 3, that's negative 8 minus 3. Those are both negatives, which means we combine them, and negative 8 minus 3 is negative 11. And then again, negative 4 times 5 is negative 20. Negative 20 minus 3 is negative 23. Ms. Dubois is starting to show off her mental math skills. So now we have negative 2 something minus 1, and in this case our first something is negative 3. So negative 2 times negative 3 is positive 6 minus 1. Our first answer is going to be 5. And then we get to do it all again. So negative 2 times, what's our number? Negative 2 minus 1. So negative 2 times, come on computer, catch up, I'm not writing that fast. Minus 1, computer. Alright, so negative 2 times negative 2 is 4 minus 1, which is going to be 3. Next up is going to be negative 2 times 0 minus 1. That's going to be 0 minus 1, which is going to be negative 1. Let's see how long it takes for my computer to catch up. It's trying to catch up. It's trying to catch up. Almost made it. Okay. Next up, it'll be negative 2 times 1 minus 1. So negative 2 times 1 is negative 2 minus 1 is going to be negative 3. And then, come on computer, catch up. Negative 2 times 5 minus 1, that is going to be negative 10 minus 1. Negative 10 minus 1 is negative 11, if our computer will catch up. Good computer. All right. So we're starting to plow through our DSA. We're looking pretty good, feeling pretty confident. This one tends to give some kids some pause, so I want to slow down a little bit. We're doing effectively this topic just a little bit different, so there's nothing exactly new here. So it's going to be f of 4, so negative 4 times 4 plus 4. Again, all you're doing is you're taking your x and you're putting in the number they give you, which in this case is 4. Negative 4 times 4 is negative 16 plus 4. Negative and a positive, that means we're going to be doing subtraction, so our answer is going to be negative 12 for our first answer. The second one is where kids tend to get a little bit stuck. They at least understand that the 3 is supposed to go where the x is, but then for some reason their brains just sort of misfire and they completely forget order of operations. So it's worth pointing it out again. For order of operations, you have PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. When you're going through this, your exponents come first. I cannot tell you the number of kids who try to tell me, oh, miss, negative 2 times 3 is negative 6, and then you square it. To which I hang my head, whack it against the nearest hard object, and say, no, exponents technically come first. So 3 squared is 9. Even at the end of Algebra 2, y'all are still doing this. So I want to make sure that you understand ahead of time, do not make this mistake. Negative 2 times 9 is negative 18 minus 3. Negative 18 minus 3 is negative 21. Okay, good. We have spared everyone the headache, especially Ms. Dubois. Now let's go through it again, and this time we're going to do a cubed. Okay, so negative 2 times negative 3 quantity cubed minus 3. A lot of 2's, a lot of 3's. So what we're looking to do here, again, exponents come first. This here is what we want to focus on first. What negative cubed means is we're doing negative 3 times negative 3 times negative 3. That is the whole point of this. That's what we're trying to do. So negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27 times negative 2 minus 3. That's what we're looking to do. So negative 27 times negative 2. Some of you may need a calculator. Ms. DuBois is going to show off and say that that's positive 54 minus 3. Our answer is going to be 51. Next one, a little bit easier. It's negative 5 times. What number did they give us? 4. Come on, computer. 4, I said. Negative, plus 2. Lost my math there for a second. Negative 5 times 4 is negative 20 plus 2. Opposite signs mean subtract, so our answer is going to be negative 18. That's what we're looking to do, okay? Now we're going to take this a little bit further. Now, instead of giving a number as an input, let's give ourselves a whole darn variable. The horror. What do we do? Well, what does x become? What did they give us? N minus 3. And then the plus 4 drops down because it hasn't been touched yet. Well, gosh and golly gee, aren't those like terms, Ms. DuBois? Can't we combine them? Yes. Yes, we can. So negative 3 plus 4 is 1, and there is our final answer. Same thing is going to be applied here. 3 something squared plus 4. And what is the something in this particular case? It is 2z. To z or not to z? Wait, that doesn't sound right. All right, so the exponent, we're going to take it to everything inside. So it'll be 3 times. What is 2 squared? 2 squared is 4. Z squared is just, well, z squared plus 4. Can we simplify it more after this? Yes, we can. We can do 3 times 4. 3 times 4 is 12. Z squared plus 4. Can we simplify it any more after that? Nope. Once we've pared it down as much as we can, we are done. It's a fait accompli. Now, again, we're getting used to those inputs for a function, only now this time, you know that inside and outside we're going to be talking about in the other half of the DSA video that I might have recorded first instead of this one. We're talking about inside and outside again. Here, we can see that our negative 2 is inside. Since it is inside, we are looking at our x value. So what we're going to do is we're going to look at x is negative 2, and we're going to find it. Where is it on the blue line? Right there. Okay, so if we're looking for g of negative 2, what's our answer going to be? Well, what's our y? 0. This one is the same idea, only now we are outside of the parentheses, which means we're going to be looking at our y value. So now we're going to be looking at y is 3, so we're going to visually look our way along y is 3, find it on our blue line, and what's our x? 1. So our g of x equals 3 will get us an answer of 1. That's what you got to keep in mind. Inside is your x value. Look at your x, find it on the blue line, what's your y? If it's outside, that's your y. So look at your y, find it on the blue line, what's your x? That's what you're looking to do. So g of x equals 4, and then g of negative 2. So this is going to be our y. Y value is 4. So if I look at my y value is 4, there it is. What's my x value? 0. Okay. Negative 2 is going to be my x, so I'm going to trace my way along the x. Where it is on the blue line? Boom, right there. What's my y value? 2. That's where we're pulling our numbers from. Then we're going to take it even a little bit further. Now we have contiguous functions. This deals with interval notation. It even says interval notation if you need a reminder from a prior video. If it is open, it is parentheses. If it is closed, it is brackets. Again, if you do not have it in your notes, well, first of all, shame on you. Second of all, write it in your notes. Domain is your x value. So domain, we want to figure out where does it start and where does it stop. It starts here, it stops here. That's a bracket, so I need, that's closed, excuse me. Since it is closed, you need a bracket. And what's my x value? Trace it up, negative 3. Over here, that is open, so I need a parentheses, trace it up. What's my y? What's my x value? 3. So far, so good. Range. Again, we're going to be going bottom to top. So we start here, and then we stop here. So we start here, that's a bracket, and what's our y value? -4. Here, this is the tricky one. We stop at 5, but what do we put here? Is it going to be a bracket or is it going to be a parentheses? Well, the question I asked you is back from Algebra 1. Is that line solid or dotted? It is solid. So if it is solid, is it or equal to or not? It is or equal to, and or equal to is always closed. That's what you got to keep in mind. So for this one, again, we're going to be looking at domain. That's from here to here. So we're going from -4 to 4. The -4 is closed, and then our 4 is open. So that's a parentheses. For range, we're going to be going from bottom to top. Bottom is -2. That's open, so we want a parentheses. And then what's our top? Our top is going to be 3. That's closed, and it's a bracket. Okay, so far so good. We're looking pretty good at this. Look at all of that math we've done. It's amazing. So now, let's do some more math. Yay! All right, so now we're going to zoom in a little bit, and we're going to zoom in, and now we're going to go back up here. So what do we have? We are finding whether a function is increasing, decreasing, constant given the graph. Okay, so you want to look here for this sentence. Here specifically it's looking for decreasing. So it's going down here and it's going down here. Now this is a trick because a lot of kids see the brackets and the parentheses and they're like, oh my God, I got to figure out which is which. What do I do? What do I do? But again, the computer is going to try to trick you. You're always using the parentheses. So where do I start? Where do I stop? And here's the other thing, you're only looking at x values for this. So where do I start from here down? I start at -5, comma. Where do I stop? Trace my way. It's going to be at -2. Also, and don't forget the comma, for the love of heaven, don't forget the comma. Where else do we go down? Here and here. What's my start? What's my start? Stop. My start is at 3. My stop is at 5. That's what you're looking to do, and this then is going to be our answer. So again, you're only tracing x values, and you are only looking at parentheses. Now on the DSA, those are the only two things I'm allowed to tell you. I am allowed to say x values, and I'm allowed to say parentheses. You have to be able to figure it out on your own after that. Here, for this next example, we're looking for constant. Constant, if you recall, is flat. So we have two cases of flat. We have here and we have here. So what are our values? Computer, catch up. Our values over here, while my computer is catching up, we start at -6 and then stop at -5. Again, we know that because we're tracing our way down. And then our next time it's constant is going to be from -3 until 1. Again, because it's tracing its way down. And that's how you're going to be doing that topic. Next up, intercepts for a nonlinear function. This is another one on the DSA question where it's actually kind of low-key easy. So, what are the x-intercepts? X-intercepts. Where does it cross the x-axis? Gee, I don't know. It's so hard. Whatever could it be? It's -4 and 0, okay? Y-axis. Where does it cross the y-axis? Well, gee, I don't know. What could it be? 0. Over here, same idea. If we're looking for our x-intercepts first, where does it cross the x-axis? Right here. What's my x value? 1. Computer, catch up. Computer. Good computer. Y-intercept, where does it cross the y-axis? Right there. And what's the number for that? That is -1. Computer, catch up. Okay. Next, this here is the last question, number 20 on the DSA. Everyone's favorite because they always get one wrong and one right. So we're going to do this in pieces. We want to look for our key phrases. Increases steadily, then levels off, then increases again. So there's 3 parts to this graph. Increasing, flat, increasing. Which one has increasing, flat, increasing? Just this one. Police helicopter takes up straight up from the ground. It ascends, let's see here, several feet, and then flies straight ahead at a constant height, and then key phrase. Literally key phrase. They should have italicized it if it were me. Without changing height, it turns and flies towards headquarters. So even though it's telling you 3 things, the chart itself is only doing 2 things. It's raising and then it's flat. So therefore it's going to be this one. So if there's one of 2 places where people go nuts, this is one of them. If they give you something like without changing height and they don't actually advertise that. Here is another one. That more often than not is where kids start to go a little screwy with this. So let's think about what we're doing. Driving at a constant speed, stop for several minutes, and then starts up again at a faster speed. Here's what kids will try to tell me over and over. They try to say constant speed, but that's not what my y-axis is telling me. If it's a constant speed, that means I'm consistently gaining ground. And then the other thing is it's the distance to Mark's house. So when you guys go to school and you get on your little bus and come to Cheney, and you're going to school all the way over to the schoolyard, you know, with your little flag and everything, the question you got to be asking yourself is, that's a terrible school, is the distance going up, going down, or staying the same? Because you're driving to the school, your distance is going down. So whenever you see distance to something, I cannot stress it enough. If your distance is to something, you start with going down, which means 2 of these graphs have been eliminated by default. So now we can actually look at this. Constant speed, stop for several minutes. That means your distance doesn't change, which means it's flat. Process of elimination. Next, Charmin is driving the freeway at a constant speed, and now we're measuring speed, so speed is flat. So 2 of these are crossed out. Speeds up to pass a truck, which means it's going to be this one, and then slows down. It doesn't say anything about a stop, and so that's how you're going to be doing this particular topic. So that is our first round of topics for DSA 1. This is, give or take, about the first 12 topics of the chapter, of the DSA, and now you know how to do every single one of them without any change or any deviation, and you're finally going to start feeling confident as you take the tests. Next video, or prior video, depending on the recording chronology, we're going to be talking about transformations, which is the next big thing. As always, stay happy, stay healthy, stay safe. I'll see you in the next one.